Alright, so we're going over this worksheet, section 2.6, and we're going to take a quiz on this tomorrow, okay? So this is basically your review. So let's go in order, is that alright? Numerical order, so let's go 2 first. So what do I got? 2 over 7p minus 2. Tell you what, I'm going to put that over 1, is that alright? Since I got a couple things that are fractions here. Just makes it look a little nicer, I think. Alright, well, let's see. We're not really subtracting fractions from each other, are we? Not technically. What are we trying to do? We're trying to get rid of these denominators. So how do you get rid of a denominator? Well, you multiply it by its least common multiple, or its common denominator. Remember that? Okay, so I've got 7 and 8. What's a common denominator with 7 and 8? 56. And then I have one p here and one p here, so it's just 56 what? P. So I multiply everything by 56p. Multiply this by 56p, and multiply this by 56p. Make sense so far? Okay. Let's see why we did that. The whole reason we did that is so that this denominator will cancel with something up here. So the denominator will cancel out. And same thing with this thing. This 8p right here will cancel out with this 56p. Thank you. So let's see what happens. Well, the p's cancel out. That's easy to see. Well, the 7 goes into 56 how many times? 8 times. See that? Nothing cancels out here, right? Because it's a 1 on the bottom. What about here? This goes into this how many times? 7, right? Because 8 goes into 56 7 times. You okay with that so far? Alright, let's clean it up. Looks a little messy right here, but let's clean it up. What do we have here? Now that p canceled out too, didn't it? With this down here, so it's just an 8 times 2, which is 16. Minus. Nothing cancels out here, so I just multiply that together. What's that? 112? Is that right? P? Okay, equals. That whole thing canceled with this, leaving a 7, so I got to take 7 multiplied by 3, which is just 21. And now you just solve for p. Subtract 16 from both sides. So it's negative 112p equals, what's that, 5? Divide by negative 112. That looks familiar. That's the answer I read off, isn't it? Does that make sense? Alright, so again, the whole idea is when you have fractions, they're called rational equations. Rational meaning ratio, right? Ratio meaning fractions. Equations. So if I have an equation and I have fractions on here, the easiest way to do this, there's other ways to do this. This is not the only way to do it, okay? But I think the easiest way to do it is to get rid of the denominators. And how do you get rid of the denominators? You multiply everything by the common denominator. That way, the 7p completely cancels out and the 8p completely cancels out. That's the whole reason for multiplying everything by 56p. Does that make sense? Okay. Alright, that was number 2. Let's do this nice blue right here. Let's do number 5. Scooch this up. Alright, another one of these kind. So negative 3x over 14. Say x. Let's see where we got. Plus 16x minus 1 over 28 equals 4x minus 1 over 20x. Okay. Now look, this denominator might be a little bit tougher to find than what the denominator was before. 7 and 8, you just multiply the 2 together. It's easy as that, right? Let's take a look at 14, 28, and 20. Remember what I said, we're multiplying by the least common multiple. All right? We could just multiply all 3 of those together, actually 4 with the x right here, and then that would all cancel out. But then you got some big, gigantic, huge number to work with, okay? I would rather not work with that. I think the best way is to do this. Watch. I got 14, I got 28, and I got 20. We talked about this a while back. Let's break them down into its prime factors. You know what that means? Break them down until I can't break them down anymore. Okay, that's its prime factor, so I get all prime numbers here. So what times what is 14? 2 times 7, right? Tell you what, let's do this. just so we separate them. Okay, is that all right? What about 28? 4 times 7, and then break 4 down is what? 2 times 2 times 7. If you're great, you can do that in your head, right? You don't need a little factor tree. Remember doing that a long time ago? You don't really need to do that. You can just figure that out in your head. What about 20? Well, 4 times 5, right? Take 4 and break that down. 2 times 2 times 5. So now, how do we figure out what our least common multiple is? Well, we take the numbers that show up. They don't have to show up in all 3 places. They really don't. Okay? But if it shows up in more than one place, you take the one that shows up the most number of times. So the 2 shows up here once, the 2 is here twice, and the 2 is here twice. All right? Now you're not going to pick 4 of them. It shows up twice. That's the most number of times it shows up in either of those places. You just pick one of these groups. Okay? So I circled it. What other numbers show up? Well, 5 shows up, right? It's not here and it's not here, but it doesn't make any difference. It shows up at least one of the places, so I'll circle that. What I'm going to do with everything that's circled, I'm going to multiply all those together. What other number shows up? 7. It shows up once here and it shows up once here. I'm not going to pick them both. I just pick one of them. It doesn't matter which one I pick. All right? I could have circled this one or this one. Now, what do I do with all those numbers? Multiply them together. So I've got 2 times 2 times 5 times what? Oops. I wrote 5 again, didn't I? Alright, come on, undo. Yeah, see, the first time I undo, it takes a second to do that. Alright, so let's do the multiplication easy. 2 times 5 is 10. 2 times 7 is 14, so it's 140, right? So that is what I want to multiply everything by, is 140. Does that make any sense? Now look, you could have taken 14 times 28 times 20, got some big gigantic number, and multiplied everything by that number. But that would be a little bit ugly. It's bad enough multiplying by 140, isn't it? So let's go ahead and do this. Let's multiply by 140. Let's multiply this by 140. Put a parentheses around this. And multiply this by 140. Put parentheses around that. We good so far? Ready to move on? Alright, let's see what we're going to do. Now, am I going to go 140 times negative 3x? Oh, I forgot something. What did I forget? It's not just 140. What else shows up here? There's an x that shows up, so I got to put an x on here. Almost forgot. Wow. That's important. Okay? Now watch. Let's see what happens. This 14 goes into this 140 how many times? 10 times. So what do I have? I got a 10x. But what's that 10x doing to this? Dan, you with me? What's this 10x doing to this negative 3x? Multiplying together. So I'll do that in the next step, okay, but understand that that's what you're going to have to do. What about this? 28. 28 goes into 140. Well, look down here. Where's 28? 4 times 7, that's 28 times what? 5 is equal to 140, isn't it? So that goes 5 times. Still got an x though, don't we? All right, what about this one? Now look, this x cancels out. See, that x cancels with that. The zeros cancel out, so 2 goes into 14. How many times? 7 times. I haven't needed a calculator yet, have I? And so it's just 7 times. Now, it's a big old mess right here, but let's clean it up real nice. So what do we got? We got 10 times negative 3, which is negative 30, and then x times x, which is x squared. So all that came out to negative 30x squared. What about all this stuff? Well, the denominators cancel out, right? So all I got to do, I got a 5x here, and it has to be distributed through this 16x minus 1. Tell you, can you just do that in your head, or should we write it down to make it look a little neater? Can you just do this? What's 16 times 5? It's 80, I think, isn't it? Okay, and so it's 80 what? X what? Squared. Because it's 5x and 16x, right? So x times x is x squared. Put a minus, and then it's 5x times 1, which is just minus 5x. See what I did? I took that 5x and distributed through there. If you want to make it look a little cleaner, if that looks a little ugly for you, you could have just written down 5x times 16x minus 1, couldn't you? If you wanted to do that. Alright. Equals. What are we going to do here? All that canceled with this. All I have right here is a 7. I don't have a 7x, do I? Because that x canceled with this x down here. So all I'm doing is distributing a 7 through this. We should be able to do that. That's 28x minus 7. So you look at this crazy thing. Well, it looks like a quadratic, doesn't it? So let's get the x squareds together. So I got 80x squared minus 30x squared is 50x squared. Am I right? Let's get all the x's on the same side. So I'm going to get minus 28x here, subtract a 28x here. What's that? Minus 33x, right? That goes. And then put the 7 over here. That's a minus 7, so we add a 7. So plus 7 equals 0. So look at this thing right here. That's a piece of work, isn't it? Would you try to factor that? I probably wouldn't even give it a shot, okay? I'd go right to what? I'd go right to quadratic formula, okay? So let's go ahead and do that. X equals negative b, which is 33, right? Plus or minus square root b squared. Somebody do that for me. What's 33 squared? I don't know what that is. 1089? Okay. 1089. So that's b squared minus 4 times a, which is 50, times c, which is 7, right? 4ac. All that is over 2a. Well, 2 times 50 is 100. Alright, so I got 33 plus or minus square root. Somebody do that for me. What's that? That's 200. That's 1400. So 1089. Is this working? What number am I doing? 5? Whoa. But I'll get an I, won't I? Let me pause this and think a little bit. Yeah, I'm looking at this and I think we're fine. I think we did it right. I don't think the answer is right, to tell you the truth. So let's just continue with this problem the way it is. So if I, let's see, I did this already. So 1089, and that's 1400, which is negative 311. All right, so that's 311 over 100. So that technically is your answer. I'll just keep it. Well, actually, write it as I. So 33 plus or minus, put the I out in front, square root of 311 over 100. That's how I would write the answer. That's not how they write the answer. They wrote it as 1/4 and 14/5. But I guess I would have to tend to disagree with them unless I made a mistake. That always bothers me a little bit because right there, 33 plus or minus square root of 311i.
That's what I got.
You got that when you did it?
Yeah.
Yeah. That's it. I think they probably either wrote the wrong answer down or they wrote the problem down wrong, or I don't know. I'm not really sure what they did, but I think that would be the answer right there. I don't think that's what they intended it to be, so I have a feeling that they wrote the problem down wrong, to tell you the truth. And we wrote it right, didn't we? Yeah, negative 3x over 14, 16x minus 1 over 28, and 4x equals plus, yeah. Yeah, it looks fine. I think we did it right, unless somebody would tell me otherwise. Okay. Oh, what was another one? Let's see our list. So I guess we did number 5. Let's do 12. 12, 14, 20. Is that right? Okay. Alright, let's try a different color this time. Let's go nice green here. 12. Alright, let's do this one. I don't know, we might just have enough time to do this one. We'll see. I'll try to hurry. Let's squeeze that in a little bit. Alright, minus square root of x minus 2 equals 3. Alright, so we'll add this to both sides. I'll go through this a little faster than what I did yesterday, okay? I took quite a bit of time on this yesterday. Now, I know I didn't record yesterday's going over the homework, but you should have it in your notes or your homework somewhere. Okay, here's what we're going to do. We're going to square both sides. So we're going to square this side. Now, here's the key to this problem right here. What I just did, putting that in parentheses and squaring it, to me, that's the crux of the problem, all right? That's the key. That you do that. This squaring gets rid of that square root, so I just have a 2x plus 5. Now look, A lot of people, and I've said this on several occasions, a lot of people think that squaring this right side just squares the 3 and it squares this square root of x minus 2, but it doesn't. Because when I square something, I have to multiply it by itself. That right there is the most important part of this problem. That's what we're trying to teach you in this problem, is to make sure that you square that thing. Remember how to do that? You could just do FOIL method, right? Tell you what. You could just do this. Or you could have gone directly from here, because this is a perfect square. Remember, you square the two outsides, then you multiply them up, double them, stick it in the middle. You could do that as well if you wanted to, but let's just do FOIL on it. So that's 9 plus, what's that? 3 square root of x minus 2, and this is another 3 square root of x minus 2, and what is that? That's 6 square root of x minus 2. Isn't that the same thing as just multiplying them together and then doubling it? Yeah. And then what do we got here? Plus, oh, when I multiply these together, a square root times a square root, yeah, it's basically like squaring it, right? So it cancels it out, so it's just a x minus 2. Alright? That was the hardest part of the whole problem right there, I think. Okay, now there's a lot more to this problem, but I think as far as difficulty level, I think that was the highest on the difficulty level of this problem. Alright, so let's keep going. 2x plus 5, there's really nothing we can do with that, but we can add some things over here, can't we? 9 minus 2 is 11, plus 6 square root of x minus 2 plus x. Alright, that's all I did right there, was just add the 9 and the negative 2. Let's see what we can do here. I want this 6 square root of x minus 2 to stay where it is, because I want to get rid of that square root, so I want to square both sides. So I'm not going to square this whole side, because if you squared that whole side, that would be a mess. Alright? It wouldn't just be simple, you know, FOIL method. So let's get rid of the 11, get rid of the x. And that would be easy, because watch, if I get rid of the x, right, that simplifies. Get rid of the 11, that simplifies. Everybody see that? So what do I have? I got x minus 6 equals 6 square root of x minus 2. You could do a couple things at this point. You could divide by 6 if you wanted to, but I think that might make it a little bit messier. You could do it. It probably wouldn't be all that bad, but here's what the book does. The book just takes this and squares it, and then they take this and square that. Okay? So let's do that. If I square this, it's a FOIL method again, isn't it? Now look, it's a perfect square, so let's start getting used to this. It's just x squared minus, what do? Multiply and double. So 6x, you double 6x and you get 12x. And then square this, that's a plus 36. You should be able now to go from here to here just in your head. You think you can do that on your own now? Alright, square this, multiply them together, double it, that's your middle term. Okay, if you want to go through the FOIL method, feel free to do that if you want, but I think that's a lot quicker, don't you? Alright, save you some time. Now what are we going to do over here? We're going to square everything inside this parentheses. Now there's no plus inside of this, in between the 6 and the square root, is there? So I don't have to do FOIL method. I just square the two things individually. Square the 6, which is 36. Now it's being multiplied. If I square this square root, what happens? It cancels out. So what do I have left? X minus 2. Do you understand why I don't FOIL here? Because it's not 6 plus. It's not 6 minus. It's 6 times. So for instance, off to the side, what if I did this? What if I just squared a 3x? I don't go 3 plus x times 3 plus x. Why? Because there's no plus in here, right? It's just multiplication. What do I do here? I just multiply the 3, or I just square, I'm sorry, not multiply. I square the 3, and I square the x. Does that make sense? That's exactly what I'm doing here. I'm squaring the 6, and I'm squaring this square root of x minus 2, which gets rid of the square root and becomes just x minus 2. Now the rest is pretty, I think, pretty self-explanatory. Right? It's a nice quadratic, so we'll distribute this, get all the stuff on the left-hand side, set it equal to 0, and then use either quadratic formula or factor it, whatever is good for you. So watch. Tell you what's this going to be? This is going to be 30x minus what? 72. So how do I get rid of a 36x? I subtract a 36x, correct? So I get x squared minus what? 48. And then add a 72. So if I add a 72 to that, that's 8, and that's a 10, that's 108, equals 0. Now you could try to factor that, and something may factor. I don't know. Does anything? 2 goes into this. How many times is 2? 50 what? 4? So that means 4 goes into it. What? 27? Did I do that right? Somebody do that. Who's got a calculator? 108 divided by 4? 27. All right. So does that help us get a 48? I don't know. So what did I say so far? 27 times what? 4? Is that right? Okay, so that's 108. What about this? 27 is 9 times 3 times 4. Is there any way I can get these to become a 48? That's a 12 and a 9. That doesn't give us 48. I can't really think of anything. Yeah, I can't think of anything. What number was this one? 12? Yeah, it should. Okay, I think we decided this does not factor, right? So let's use the quadratic formula. Let's do it real quick. So x equals negative b, or 48 plus or minus square root of b squared. Somebody give me, well, I got a thing here, 48 squared, right? 48 squared. 2304, okay? 2304 minus 4 times a, which is just 1, right? Times c, which is 108. And that's over 2 times a, which is just 2. So what's that? 432. So 2304. Oops. 2304 minus, what did I say that was? 432. 432 equals 1860. Oh, I can't write. 432. So what should that be? 1872. Okay. So I've got 48 plus or minus, what was that number again? 1872. Okay, over 2. I don't know. That might simplify a little bit more. That is not close to the answer that they give in the book. In the answer in the book, they give, what is this, 12? They get 2 and 38. So, again, either I screwed up somewhere or they messed up. And I think I did. I think I did. They must have been having an office party when they were writing the answers to this, right? So, who knows? All right, well, we're going to take a quiz on this, and I promise you the ones on the quiz will come out pretty nice and decent, okay? Yeah, you can hang on to this and study from it, and hopefully you study the right ones and not the wrong ones. All right.